Hey guys, welcome back to the Raptors, a digital platform of the RAPT Excellent Tutorials. Today we are going to discuss a very important topic, continuity and differentiability. This topic is extremely conceptual, and one should pay rather very sharp attention to understand this topic. So let us begin with it. We'll try to understand continuity first. So we are going through continuity. So there is a graph, suppose y is equal to fx, this graph, and this is x-axis. Assuming a graph like this, we want to check whether this function is continuous at x equal to a or not. So the continuity means that if you go very close to this point from left hand side, you reach very close to a but you don't touch a. This, the value of function when you reach very close to a but you don't touch a, that will be called left hand limit. But if you reach very close to a from right hand side, from the positive infinity side, and you don't touch a, then this value is called right hand limit value. Now for example, suppose a is equal to 2. So if you want to reach 2 from left hand side, the value should be 1.99999999 infinite nines, but it is not 2 exactly. It's very close to 2 but not 2 from the left hand side. Now if you want to reach 2 from the right hand side, you want to reach very close, that means the value will be 2.000000 infinite zeros and then 1. This value is also very close to 2 but it is not touching 2, it is from right hand side. So a function is called continuous if left hand limit at x equal to a is equal to right hand limit at x equal to a equal to value of function at a. That means we'll have to find the left hand limit, right hand limit and value. All the three should be the same. Like you are reaching a point from left hand side, should be very close to the given value but you are not touching that value, and you are also reaching that point from the right hand side, you are very close to that value but you are not touching that value. And in the third case, you want to check the value of the function at that particular point as well. So including these three, like if these three values are same, your function is said to be continuous. That means there is no break in the function. To understand, general sense, what does continuity actually means is there is no break in the function, there is no break in the graph. That is, if you are able to plot that graph without raising your pen, then the function is continuous. If you have to raise your pen to draw that graph, then the function is discontinuous. For example, let me show one function. See, you cannot plot this graph without raising your pen. Hence, this function is discontinuous. Now, we'll try to find out algebraically what does left hand limit at x equal to a means or looks like. What does right hand limit at x equal to a looks like? So let us write it down. So left hand limit is limit. Now you see, what is h? You see, you are reaching 2 from the left hand side and your value is 1.99999999. So you may say this is equal to 2 minus h, where h is very small number. And on the right hand side, you reach 2 but you don't touch 2, it is 0.2.00001. So you can write it as 2 plus h. Notice h. H is very small number, positive number, which is 0.0000, infinite zeros and then 1. It's extremely small value. So you see, you put limit h tends to 0 and it will be f of a minus h. That means you want to check on just the left hand side of your value a. A minus h means very close to a, but on the left hand side of h. So you want to find the value. Now, what will be right hand limit? Limit h tends to 0 f of a plus h. That means you want to check the value of the function just on the right hand side of the a. Now, the third thing is value of function at a. So, if these three are equal, the function is continuous, otherwise it is not. So, that's what we mean by continuity. We'll take a small example to find, to see the continuity of the function. Let us find out. Question: fx equal to 2 plus x, if x is less than 1, x square if x is greater than or equal to 1. So we need to check whether the function is continuous or not. So you see, left hand, so we need to check continuity at x equal to 1. Even if it is not given where to check continuity, one should understand the function is changing at 1. So where the function changes, there is chance of being it discontinuous is there is chance to get it discontinuous at that point, because below 1 there is single function and it is algebraic and it should be continuous. Here as well, beyond 1 you see single x square quadratic function, algebraic function, it is continuous. Now we'll see whether this function is continuous at x equal to 1 or not. So let us find out. Left hand limit at x equal to 1. So limit h tends to 0 f of 1 minus h. So it should look like less than 1 means we need to use this function. Limit h tends to 0, 2 plus 1 minus h, you put h equal to 0, 2 plus 1, that is 3. We come to right hand limit. So let us find out right hand limit at x equal to 1. It will be limit h equal to 0 f of 1 plus h. So it will be limit h tends to 0 1 plus h whole square, put 1 equal to 0, h equal to 0, so 1. So what we see from equation 1 and 2, also f of 1 is exactly 1 square, which is 1. If any one of them are not equal, then the function is discontinuous. So we can say, since left hand limit is not equal to right hand limit, fx is discontinuous at x equal to 1. Answer. So that's how one solves a continuity problem. Now we come to differentiability. We'll try to understand what does differentiability means. Uh, it is the ability to draw a unique tangent to a curve at a given point. That is, if the curve is like this, if you want to see if the function is differentiable at x equal to a, then we should be able to, if we are able to draw only one tangent at this point, then it is differentiable. If we are able to draw more than one tangent, then this function is non-differentiable. For example, let us look at this function. Here, look at this discontinuity point of, look at the point of discontinuity. We will be able to draw n number of tangents at this point, because that point is just the point of discontinuity on the function is just a dot, a point, and n numbers of like infinite lines can pass through a point. Same here. Hence, at the point of discontinuity, the function is also not differentiable. So, if a function is discontinuous, it is also not differentiable. But if the function is continuous, is it also always differentiable? The answer is no. Let us look at this. Let us look at an important function, modulus function. So let fx equal to mod x. Now the graph for this function looks like this, V graph. So it is y is equal to fx and this is x. You see at x equal to 0, this V graph has its vertex at the origin. At the origin it has got point dot, and from that dot one can draw infinite lines, infinite tangents. So you see, infinite tangents can be drawn. Hence, even though the function is continuous at x equal to 0, it is non-differentiable. So what we can conclude, every differentiable function is continuous, but every continuous function is not differentiable. So having this in the background, let us try to understand how to solve problems based on differentiability. So algebraically, a function will be differentiable if left hand derivative at x equal to a equal to right hand derivative at x equal to a. Now what is left hand derivative? It is limit h tends to 0 f of a minus f of a minus h divided by h. What is right hand derivative? It is limit h tends to 0 f of a plus h minus f of a divided by h. So if left hand derivative is equal to right hand derivative, the function is differentiable. If left hand derivative is not equal to right hand derivative, the function is not differentiable. So it is just about finding these limits and then solve the problem. There are few limit formulae which are useful to keep in mind, like limit x tends to 0, sine of x by x is 1, limit x tends to 0, tan of x by x is also 1, limit x tends to 0, cos of x by x is not defined, and then limit x tends to a, x to the power n, a to the power n, x minus a becomes n, a to the power n minus 1. So these are the important formulae limit formula, which will be helpful in solving these problems. So this is what differentiation or differentiability is. Let us solve a problem based on differentiability. Question: differentiate fx equal to sin x by using first principles. By using first principle, we are going to differentiate fx equal to sin x. Now solutions. Now f dash x will be limit h tends to 0, f of x plus h minus f of x divided by h. Now here I chose right hand derivative, one can choose left hand as well. So it doesn't matter, one can choose, one can go ahead with either left hand derivative or right hand derivative. So I'm choosing right, you can go left. Now f of x plus h will be limit h tends to 0 sine of x plus h minus sine of x divided by h. Now sine of, will expand sine of x minus h, so we'll get sine x cos h cos x sin h minus sin x divided by h. Limit h tends to 0. We take sin x common here, so you get cos h minus 1 plus cos x sin h divided by h. Now what we'll do, this is sin x, and then we'll split, I will take this by h divided by that by h. So cos h minus 1 will be so we'll use cos 2h formula to I'll use 1 minus 2 sine square h by 2 minus 1 whole divided by h plus limit h tends to 0 cos x into sin h by h. This 1 and 1 gets cancelled. We have limit h tends to 0 sin x, and then we'll take 2 outside with negative outside, and then sine of h by 2, we multiply by h, and then denominator becomes h square, we divide by 4 and multiply by 4. So you see h gets cancelled, you get single h, 4 gets cancelled, so this is square. Now here sin h by h, as I reminded last time, sine of x by x is 1, so this becomes 1, you get cos x. Now here minus 2 sine x and then h by 4, no, let h by 4 be inside. We have limit h tends to 0. So what I'm doing, I'm taking minus 2 sine x outside because it don't depends on h. Now here we have h by 4 and then sine of h by 2 divided by h by 2 whole square. Now this sine h by h will become 1, this portion will become 1, but this h equal to 0 will make the whole term 0, and then we have cos x. So this whole term becomes 0 because of this h. You know the sine h by 2 by sine h by 2 will be 1, but this term will make this whole term 0. So this term becomes 0 and we are left with just cos x. So differentiation of sine x is cos x. This type of question can be asked, but the probability is very low, but this can be asked in the board exam. Now guys, taking the revision forward on differentiation, we'll try to understand what different kinds of differentiation rules are there, what different kinds of differentiations are there. So let us see differentiation of a composite function. Composite functions are the functions which are embedded function. There will be a function inside a function. So let us take an example. If the function looks like f of gx and then you want to differentiate it, you should treat the other function which is embedded inside, which is in the argument of the outside function. You should treat that function as normal x. So its differentiation will be f dash normal x. But you see, this embedded function is not plain or normal x, so you need to differentiate it with respect to x again. So your final result becomes f dash gx into g dash x. Let us take an example. Suppose we want to differentiate log of sine x. Now I'll treat the sine x function which is inside the argument of log x to be positive, to be just x. So we need to find out differentiation of log x. So what is differentiation of log x? Just 1 by x. But you see, this x was not normal x, it was a function sin x, so we need to differentiate sin x. Now this differentiation of sin x will be cos x divided by sin x. See, here you can also try differentiating this x as well. So it will be ddx of x by x. So it's just 1. So that is why we ignored this x while differentiating. The rules are same. See, here we considered sin x to be x and we differentiated this x. And inside sin x there is x. We should also differentiate that, but then we get just 1. That is why we generally ignore differentiating the argument x, because you're going to get 1, just 1. So this becomes cot x. So differentiation of log sin x is cot x. Now the other kind of differentiation is implicit function. In implicit function there will be mix of x and y. We need to differentiate such function and bring dy by dx on one side and differentiate the whole function. So let us look at it. Suppose we have x square plus xy equal to y square equal to 5. Find dy by dx. No answer. Differentiating equation 1 with respect to x both sides. So what we get? ddx of x square xy plus y square equal to ddx of 5. Now on the right hand side we have constant, its differentiation will be 0, but on the left hand side we can differentiate. So what we get? 2x. Here we are going to use UV rule, product rule. So we'll take x outside and differentiate y, and then we'll take y outside and differentiate x. So it is as a result of product rule. Now y square will be 2y dy by dx. The whole thing is 0. Now you see, we collect this dy by dx, this is just 1, so it is 2x plus y, because this is just 1, and then we take dy by dx common here, so we get dy by dx into x plus 2y equal to 0. I'll take this term on the right hand side, therefore dy by dx becomes this term right hand side 2x plus y, and then we'll divide by this term x plus 2y. So that is how one differentiates implicit functions. All right. Now the next type of differentiation is in parametric form. In parametric form, a function x and y will depend on some other parameter. For example, let us take x equal to a cos t and y equal to a sin t, or a square sin t. Doesn't matter. A, where a is constant and t is that parameter. So if this is this, find dy by dx. Now in this case what we need to do, we have a equal to a cos t, we differentiate it with respect to t, dx by dt becomes minus a sin t, and we differentiate y as well, so dy by dt becomes a square cos t. Now dy by dx will be dy by dt whole divided by dx by dt. See, dt will get cancelled and we'll have dy by dx. So dy by dt is a square cos t and dx by dt is minus a sin t. A gets cancelled and we have minus a cot t. Therefore, dy by dx is minus a cot t. The other kind of differentiation is of the other kind of differentiation is logarithmic differentiation. How to do logarithmic differentiation? Let us look at it. If y is equal to x to the power sine x, find dy by dx. So the sign that it is a logarithmic differentiation, that you need to use logarithm to differentiate, is if you see the function has some function in its power. If the function looks like this, that you have function over a function, that is a function is sitting in one function's power, that is a variable should be as a power of another variable. In this case one will have to use logarithm, there is no other way. So we take y equal to x to the power sine x, we take log both side, you have log y is equal to sine x log x. Now we'll differentiate both sides, we'll use UV rule here. So differentiating both sides with respect to x, we get log y differentiation will be 1y and then dy by dx, because it is another variable, we are differentiating it with respect to x. Here we are going to use product rule, so sin x ddx of log x, u outside v differentiation and then v outside differentiation of u. So it is sin x by x plus log x into cos x. Now what will be dy by dx? Y will get cross multiplied. So dy by dx will be, if you cross multiply y, what is y? X to the power sin x. So x to the power sin x gets cross multiplied, you have sin x by x plus cos x into log x. So that is how one does logarithmic differentiation. So the point that one should keep it in mind is, whenever you have function in power of a function, of a variable, logarithm is the key. One should use logarithm to differentiate. The other type of question is like generally which is asked is to find higher order derivative, like if y is equal to sin x, find d2y by dx square. So we solve it, dy by dx becomes cos x and then differentiate it again, we get minus sin x. So we get d2y by dx square minus sin x plus sin x equal to 0, and you see sin x equal to y, so you get d2y by dx square plus y equal to 0. So in question you may be asked to prove that if y is this, prove that this is equal to 0. So that's how one does that. Higher order derivative is not a problem. One should understand the basics of those kinds of derivation, like composite function, and then one has parametric form, then logarithmic form, then implicit function. These were the forms that one should keep in mind. That's all we have from differentiation.